So this one says to draw a picture. The picture on these ones is going to help because we're going to be combining shapes now. And this one specifically is a silo. So a silo, not that anyone knows what that is. Never mind then.
Where are you gonna duck?
All right, here we go. It just sounded like a horror movie, that's all. All right, silos. A silo is a storage bin that is a cylinder with the hemisphere on top.
Told you.
So let's draw this thing up in here because drawing is just so great. All right, so the silo up in here. We're going to draw ourselves. That didn't turn out very well. There we go. All right, so we got a cylinder right here. But then, this is Mr. Sal. Welcome to the channel. Today we're going to be talking about cylinders, spheres, and cones. Yeah, don't forget to like, subscribe, and comment. All right, so on top of this cylinder, we've got also a half sphere right here. So if we split these up, we got the half sphere, like these. Maybe you guys prefer to see that a little differently, so this would be dashed up in here. Right, because this one is like these. And then that half sphere also sits on top of the cylinder, like these. Alright? So, to find the dimensions of these, we'll just list them as they tell us. A farmer has a silo with a base radius of 30 feet. So that means that the radius on these would be 30 foot. Which means the radius on these is 30 foot. But also the radius of the cylinder is also 30 foot. Now, there's a storage height of 100 foot. So that means from the tip of this thing to the very bottom would be 100 foot. Now this should help us to find the height of the cylinder because the radius was 30 foot. So from the middle of this, or the top of the cylinder, to the top of the hemisphere would also be 30 foot, which means the height of the cylinder is 70 foot. See, and now we have all of the measurements we need to find the volume of both of these. So that's after splitting it up, and we don't really need to show the height of the hemisphere because it's just the radius, 30 foot. All right. The storage height is the part which can be filled with grain, so it is just the cylinder. Oh, let me take that back. See, that's why we should read all the way through. All right, so as it turns out, the 100 feet is the height of the silo, of the cylinder, rather. So we're going to have to replace those values. So that came after reading the whole thing through, which we should do all the time. The storage height, that's good. Now a cubic foot of grain, which we should write this in. 1 cubic foot will hold 62 pounds of, I guess this is wheat. It's grain. I got it. I don't know what the difference is. Now it says, how many pounds of grain can the farmer store in the silo? So to figure these out, we need, since the cylinder is all that we can fill on these, we need to find the volume of the cylinder. So the volume, specifically of the cylinder, will be pi r squared times the height. And we have the height at 100 foot. And the radius was given as 30 foot. So to find the volume of the cylinder, we're just going to multiply those out. So I got 282,743 point, we'll just say 3. And that would be in cubic foots. That is the cubic footness of the cylinder. But we didn't want to know the cubic footness. What we wanted to know is how many pounds that will hold. So, yeah, since it's 1 cubic foot is 62 pounds, we're going to take that 282, 743.3.
17 million pounds.
And multiplied by 62 pounds. Now, this should make sense. It's a big number. Because farmers, well, they usually take in a lot of grain. Small number.
Of course.
1753008.6, and this would be in pounds right account. Now we could show the changes right account. 17,530 and 84.6 pounds. How high, including the hemisphere top, is the silo? So it's not asking for volume yet.
It's asking for height.
It's just asking for the height,
We are saved.
which is 100 foot, but then the 30 foot from the radius of the hemisphere, 130 foot.
Seriously?
So we'll show that 100 plus the 30 equals 130 feet tall. That's pretty tall, actually. 1,000 square foot of wheat produce 250 pounds of grains. The farmer's wheat field is 3,500 feet by 20,000 foot. Is the silo large enough to hold the grain? If so, by how much? And we will explain our answer. Here we go. All right. So we'll look at a picture of this and figure out how many square footage of grain we can have, which will then tell us how many pounds of wheat or grain rather that this would produce. So that's just it doesn't matter what it's like, but this should be rectangular in shape or shapeage. And up in here we see that this is 3,500 square foot, a foot rather, by 20,000 foot. So if I wanted to find the area of these, I would have my 3,500 multiplied by my 20,000, which should give me an area of 7, 0, 1, 2, 1, 2, 3, 4. So I got 70 million square footages. Yeah, this is just the area. And what we really want here now is how many pounds of grain that will be. Now this says that 1,000 square feet will give us 250 pounds of grain. So let's figure out how many thousands that is. So we got our 70 million square footages. And if we divide this by 1,000, then we will know how many thousands of square footages we have. So yeah, you could just cancel out the zeros, but in any case, this is 70,000 square feet, which I can now multiply this by the 250, which would tell me exactly how many pounds we would expect from this farmer's field. All right, so this gave us 17,500,000 pounds.
That's like how much I weigh.
Pounds of grains. Well, going back to what we have right here,
If the farmer decides to fill
the silo will hold, if it's just a cylinder, by the way, it's going to hold that 17,530 and some change on that, okay? All right. Well, so the answer to that one is yes. Yes, it will. But then it says, by how much? So we got to figure out what that is. So we're going to subtract the 17,500,000 of pounds. And that would give us 84.600. Looks like it was 30,080. That's a zero. 30,084.6 pounds. That is how many more pounds we could fit into the silo. And we explained our answer by showing our work. Bam. Yeah, so this one has many, many steps on it, these. But then we have this last part. If the farmer decides to fill the silo all the way to the top of the hemisphere, how many cubic feet of grain can he store? So we're not looking at how many would be left over. But this is a hemisphere, but we have to treat it first like a sphere. All right, so let's come back to these. All right, so we're going to use this hemisphere. Matt will show you. Good luck.
Okay. So we know from here that the volume of the cylinder is, is this much. So we now figure out that if we find the area, oh shoot. Okay, sorry.
Let me see this actually. Please continue.
Okay. So we know the volume of the cylinder, so we just gotta find how much the volume of the sphere divided by 2 is. So we know the radius, which is 30. So we're gonna 30 square I cubed times 4 times pi divided by 3. And after we're gonna have to divide that by 2. So if we calculate that, it gives you 30 times 4 times pi divided by 3, and then that equals 1, 1, 3, 9, 7, 4. So we got that. Then we're going to have to divide that by 2, which gives us a total of 5, 6, 5, 4, 8.67. Okay. They're going to have to add that to the volume of the cylinder, which was 2, 8, 2, 7, 4, 3, 0.3.
Which one are we on? Are we on task 2? Okay.
Which gives us a total of 339,291.97. Oh wait, hold on. Feet cubed. Boom. Science.
There we go. Excellent work. All right, so that's what we got on these. 339,291. You could say 92 if you wanted to round it. In cubic foots. Now, it didn't ask us how many pounds that was, and that's okay. We could figure that out, but it didn't ask us to, so we're not going to worry about that. A snow cone consists of a cone filled with flavored shaved ice topped with hemisphere of flavored shaved ice. The cone is 4 inches long and the top has a diameter of 3 inch. Alright, well, let's get a picture drawing of this. So I got my circle and then I got my cone up in here. And then on top of this cone, we're going to put a half sphere. Like these. So, alright, I'm going to continue with these problems. So we can see that the height of the cone is 4 inches up in here. And then we got a radius of the hemisphere and of the cone actually, which is the same. It gave us the diameter actually of 3 inches.
That's a huge snow cone.
So if the diameter is 3 inches, then the radius
It's 1.5.
is going to be half of that and 1.5. Very good.
That's big. Because half of it is 3 inches. No, wait, you never actually get the snow cone.
That's much better. So we got 1.5 inches on the hemisphere as well. So the next question is, how much shaved ice in cubic inches is there altogether? This is great because we don't have to convert it into anything just yet. So to find the volume of the cone first, volume of the cone, this is just the cone, which is pi times the radius squared times the height divided by 3. But we do have the radius and the height as well. So let's go ahead and replace those in here. So this I can put now into my calculator, which will give me the answer in inches cubed. Alright, so the volume of the cone is 9.42 inches cubed, but the hemisphere also has some snow cone as well. So we're looking at this as a hemisphere, which will be pi, well actually 4 pi, times the radius cubed divided by 3, but then we got to divide that by 2. So we're going to replace the radius with the 1.5 that we know it is. And I will solve this directly. So I got 7.07 inches cubed would be B, 7.07 inches cubed. Alright, so to find the total cubic inches, we got to add those together. So adding these, 2 and 7 is a 9er, 4 and 0, 9 and 7, 16.49. So this would be 16.49 cubic inches of shaved ice. Now we got this next one. If 6 cubic inches of flavored ice is equal to 1 ounce, then how many ounces of shaved ice is that? So we're going to divide this by 6, because every 6 of those would give us 1 ounce. So this answer will be in ounces, and we divide it. Alright, so it'd be 2.75 ounces, right account. Then finally, if 1 ounce of flavored ice is 50 calories, then how many calories would this be? Well, we got 2.75 ounces. Every one of them is 50 calories. So we'll multiply this by 50, and we get 137.5 calories. Bam. Task 3, pipes. Which will carry the most water? Explain your answer. We got 2 pipes, each 100 centimeters tall, one with a 3 centimeter radius and the other with a 4 centimeter radius. But on the other hand, we have the one pipe that is also 100 centimeters tall, but with a 5 centimeter radius. What we got to do is figure out which of these 2 will carry the most water, the 2 pipes or the 1 pipe. So let's look at the 2 pipes first.
Together, that's 7. 7's bigger than 5.
All right, so let's draw these out. We got this pipe right here, and then we got the one that's just a little bit bigger right here. These would be the 2 pipes. So these are 100 centimeters tall, both of them.
One of them is 200.
And then one has a radius, we'll say that this one has a radius of 3 centimeters. And this one has a radius of 4 centimeters. So we got to find the volume of both of these. So we got the volume of the small one, which is pi r squared times the height. But we have the radius and the height for both of these. The radius of the small one is 3. Yeah, and we have pi. That's good. I do like me some pi. So the volume of the small one appears to be... Alright, so that's the volume of the small one. Now we want to look at the big one. So again, the volume is pi times the radius squared times the height. The height is the same on this, but the radius is different. The radius now is 4 on this one. And we're going to have to add those 2 volumes together as well. So this new volume of the big one is... I got something a little different on mine. I got 5,026.5.
I didn't click the pipe.
Alright, next up, let's go and add these together to find the total volume of the 2 pipes. Alright, so we got 9.135, 7853.9 centimeters cubed. Alright, now we got to find the volume of that 1 pipe. So this one is just a little bit thicker, but it has the same height. The height of 100 centimeters. But this one has a radius of 5 centimeters. So when we find the volume of these, we still got pi r squared height. The height is the same, 100. And the radius on this one is 5 though. So my volume on this, that's good. So this one gave me 7,853.98 on this one. And that one is also in centimeters cubed. Now we did some rounding on that other one. So it depends. Just looking at this, the one pipe holds just a tiny bit more. But if you said that they're equal, that would be fine as well. Fruit, a cantaloupe, a diameter of 23 centimeters, and a clementine orange has a diameter of 7 centimeters. Predict how many times bigger the cantaloupe is than the orange. I don't know, 5 times maybe? That sounds
No, I think
good.
it's like 35 times.
Nice, that's close. Let's find out. Let's find the actual volume of the fruit and determine how many times bigger the cantaloupe is bigger. Alright, let us start first with the old cantaloupe.
The radius is 11.5.
On
Crabs.
the cantaloupe.
Yep.
Oh, very good. So we got this sphere-ish with a radius of 11.5 centimeters, because the diameter was 23 on this. So to find the volume of the cantaloupe, 4 pi times the radius cubed divided by 3, but we have a radius of 11.5. So plugging this into the calculator give me a volume. Alright, so that is the volume of a cantaloupe. Let us look now at the orange, which apparently is much smaller. Alright,
It's actually 11.
so this one's going to be a little bit smaller on these. Now again, that's a diameter of 7 centimeters, so the radius is 3.5 centimeters. So when we want the volume of a these, we have the same formula, 4 pi r cubed divided by 3. And the new radius here is 3.5. So in solving for the volume, which will be in centimeters cubed, so this one actually is much smaller. To figure out how much smaller it is, we're going to take the volume of the cantaloupe, 6370.6, and divide it by the volume of the orange, 179.6. And this will tell us how many times bigger it is.
It's 35.47.
That's it. 35, we'll just round it, 35.5 times bigger. Bam.